Computer engineering is a discipline that integrates several fields of electrical engineering and computer science required to develop computer hardware and software. Computer engineers usually have training in electronic engineering, software design, and hardware-software integration instead of only software engineering or electronic engineering. Computer engineers are involved in many hardware and software aspects of computing, from the design of individual microprocessors, personal computers, and supercomputers, to circuit design. This field of engineering not only focuses on how computer systems themselves work, but also how they integrate into the larger picture. Usual tasks involving computer engineers include writing software and firmware for embedded microcontrollers, designing VLSI chips, designing analog sensors, designing mixed-signal circuit boards, and designing operating systems. Computer engineers are also suited for robotics research, which relies heavily on using digital systems to control and monitor electrical systems like motors, communications, and sensors. In many institutions, computer engineering students are allowed to choose areas of in-depth study in their junior and senior year, because the full breadth of knowledge used in the design and application of computers is beyond the scope of an undergraduate degree. Other institutions may require engineering students to complete 1 year of general engineering before declaring computer engineering as their primary focus. History: the first computer engineering degree program in the United States was established at Case Western Reserve University in 1972. As of October 2004, there were 170 ABET-accredited computer engineering programs in the U.S. In Europe, accreditation of computer engineering schools is done by a variety of agencies part of the ECONE network. Due to increasing job requirements for engineers who can concurrently design hardware, software, firmware, and manage all forms of computer systems used in industry, some tertiary institutions around the world offer a bachelor's degree generally called computer engineering. Both computer engineering and electronic engineering programs include analog and digital circuit design in their curriculum. As with most engineering disciplines, having a sound knowledge of mathematics and science is necessary for computer engineers. Work: there are two major specialities in computer engineering: software and hardware. Computer software engineering. Computer software engineers develop, design, and test software. Some software engineers design, construct, and maintain computer programs for companies. Some set up networks such as intranets for companies. Others make or install new software or upgrade computer systems. Computer software engineers can also work in application design. This involves designing or coding new programs and applications to meet the needs of a business or individual. Computer software engineers can also work as freelancers and sell their software products applications to an enterprise individual. Computer hardware engineering. Most computer hardware engineers research, develop, design, and test various computer equipment. This can range from circuit boards and microprocessors to routers. Some update existing computer equipment to be more efficient and work with newer software. Most computer hardware engineers work in research laboratories and high-tech manufacturing firms. Some also work for the federal government. According to BLS, 95% of computer hardware engineers work in metropolitan areas. They generally work full-time. Approximately 25% of their work requires more than 40 hours a week. The median salary for employed qualified computer hardware engineers was $100,920 per year or $48.52 per hour. Computer hardware engineers held 83,300 jobs in 2012. Specialty areas. There are many specialty areas in the field of computer engineering. Coding, cryptography, and information protection. Computer engineers work in coding, cryptography, and information protection to develop new methods for protecting various information, such as digital images and music, fragmentation, copyright infringement and other forms of tampering. Examples include work on wireless communications, multi-antenna systems, optical transmission, and digital watermarking. communications and wireless networks. Those focusing on communications and wireless networks work advancements in telecommunications systems and networks, modulation and error control coding, and information theory. High-speed network design, interference suppression and modulation, design and analysis of fault-tolerant system, and storage and transmission schemes are all a part of this specialty. Compilers and operating systems. This specialty focuses on compilers and operating systems design and development. Engineers in this field develop new operating system architecture, program analysis techniques, and new techniques to assure quality. Examples of work in this field includes post-link time code transformation algorithm development and new operating system development. Computational science and engineering. Computational science and engineering is a relatively new discipline. According to the Sloan Career Cornerstone Center, individuals working in this area, computational methods are applied to formulate and solve complex mathematical problems in engineering and the physical and the social sciences. Examples include aircraft design, the plasma processing of nanometer features on semiconductor wafers, VLSI circuit design, radar detection systems, ion transport through biological channels, and much more. Computer networks, mobile computing, and distributed systems. In this specialty, engineers build integrated environments for computing, communications, and information access. Examples include shared channel wireless networks, adaptive resource management in various systems, and improving the quality of service in mobile and ATM environments. Some other examples include work on wireless network systems and fast Ethernet cluster wired systems. Computer systems, architecture, parallel processing, and dependability. Engineers working in computer systems work on research projects that allow for reliable, secure, and high-performance computer systems. Projects such as designing processors for multi-threading and parallel processing are included in this field. Other examples of work in this field include development of new theories, algorithms, and other tools that add performance to computer systems. Computer vision and robotics. In this specialty, computer engineers focus on developing visual sensing technology to sense an environment, representation of an environment, and manipulation of the environment. The gathered three-dimensional information is then implemented to perform a variety of tasks. These include improved human modeling, image communication, and human-computer interfaces, as well as devices such as special-purpose cameras with versatile vision sensors. Embedded systems. Individuals working in this area design technology for enhancing the speed, reliability, and performance of systems. Embedded systems are found in many devices from a small FM radio to the space shuttle. According to the Sloan Cornerstone Career Center, ongoing developments in embedded systems include automated vehicles and equipment to conduct search and rescue, automated transportation systems, and human-robot coordination to repair equipment in space. Integrated circuits, VLSI design, testing and CAD. This specialty of computer engineering requires adequate knowledge of electronics and electrical systems. Engineers working in this area work on enhancing the speed, reliability, and energy efficiency of next-generation very large-scale integrated circuits and microsystems. An example of this specialty is work done on reducing the power consumption of VLSI algorithms and architecture. Signal, image and speech processing. Computer engineers in this area develop improvements in human-computer interaction, including speech recognition and synthesis, medical and scientific imaging, or communication systems. Other work in this area includes computer vision development such as recognition of human facial features. Education. Most entry-level computer engineering jobs require at least a bachelor's degree in computer engineering. Sometimes a degree in electrical engineering is accepted, due to the similarity of the two fields. Because hardware engineers commonly work with computer software systems, a background in computer programming usually is needed. According to BLS, A computer engineering major is similar to electrical engineering but with some computer science courses added to the curriculum. Some large firms or specialized jobs require a master's degree. It is also important for computer engineers to keep up with rapid advances in technology. Therefore, many continue learning throughout their careers. Job outlook in the United States, computer software engineering, according to the U.S. Bureau of Labor Statistics, computer applications software engineers and computer systems software engineers are projected to be among the faster-than-average growing occupations from 2012 to 2022. BLS reports an expected growth of 22% for software developers from 2012 to 2022. In addition, growing concerns over cybersecurity add up to put computer software engineering high above the average rate of increase for all fields. However, some of the work will be outsourced in foreign countries. Due to this, job growth will not be as fast as during the last decade. Computer hardware engineering, according to the BLS, employment of computer hardware engineers is expected to only increase 7% from 2012 to 2022 and is down from 9% in the BLS 2010 to 2020 estimate. Today, computer hardware is somehow equal to electronic and computer engineering and has divided to many subcategories, the most significant of them is embedded system design. Similar occupations and field, computer programming, electrical engineering, software development, systems analyst, references.